Hello everyone, I welcome you all to the fascinating globe of working stress method. In this particular video lecture, we will be discussing about the working stress method. But before moving toward the working stress design method, we will first understand the basic design equation in any design subject of civil engineering. The basic design equation says that for safe construction, for safe design, the design strength should be greater than or equal to the required strength. The threshold is that the design strength is equal to the required strength. It should not be less than the required strength. So remember, this is the main basic equation of a design subject in civil engineering. So now in this subject, we are also discussing this equation and achieving through different design philosophies. We are achieving this design equation that the design strength should be greater than or equal to the required strength. So what is the required strength? The stresses developed due to the applied loads, working loads, or different load effects. The stresses developed to this applied loads, load effect, that are called the required strength. So for any required strength, we will construct. For any required strength, we are constructing any structure to bear the required stresses. For the required strength, we are construct any structure which bear these stresses to serve the purpose for it was construct. So the design strength or the strength which is the section through section property. It is the ability to resist these applied the required stresses. So design strength can be calculated by formulas given by different codes, ACI code and LRFD design codes, AISC codes. So design strength can be calculated through formulas which are, so we are calculating the design strength and required strength, then by seeing to the condition that it is provides greater or less value, then by deciding this we will consider its fail, it may not fail. So basic 3 design philosophy also covers using different load factor, strength reduction factor. The main purpose is that the design strength should be greater than or equal to the required strength. Here we are using the word strength. Strength means in terms of moment, in terms of shear, in terms of load. So if we are using, this is the general form, that the S is the nominal strength multiplied by this phi, which is the strength reduction factor, and U is the ultimate load. So by this is the general form of this in alphabets and some letters, Greek words. So in terms of moment, this equation will be this, that the nominal moment of any section multiplied by strength reduction factor should be greater than or equal to the ultimate moment, the moment produced by the load effects that were the working load, applied load. The moments produced by these loads are called ultimate load. Now the Mn is called nominal moment, the moments, the resistance provided by the section to resist the ultimate moment. This is called nominal moment. This can be calculated by formula multiplying it by strength reduction factor. We will gain the design moment. Design moment should be greater than or equal to the ultimate moment. Similarly, for shear, if there are shear forces apply, then we are using this, that the nominal shear multiplied by strength reduction factor should be greater than or equal to the ultimate shear. So by seeing the different load effects, if the load effect is moment, then you will using the calculating the nominal moment multiplying by strength reduction factor. If the load effect or shear, then by calculating the nominal shear of a section of any structure multiplying by strength reduction factor, we will gain should be greater than the ultimate shear. So design shear should be greater than the ultimate shear. Similarly, for point load, the nominal point load multiplied by ultimate strength reduction factor should be greater than or equal to the ultimate load produced by the load effect. So these are the different elements of a design strength in terms of moment, in terms of shear, in terms of load. Now jumping toward the today's objective, that were the working stress method. Working stress method is also called allowable stress design method or elastic design method. By elastic, you also know that it holds up to the yield point. After yielding, it may not be hold that after yielding, if the section failed, then it not considering the working stress method. Up to yield point, where the stress strain curve is linearly elastic. So up to this point, this is the main assumption of the working stress design method. In this, we are using the factor of safety to reduce the strength of a section or any structure. The nominal strength are decreasing, so for this it leaves the oversized section due to the reduction in strength, the nominal strength. Remember this, the members properties are decreased. For this, large section are required to bear the required strength, the load effects. So this is the general equation of the design, that the design strength should be equal to or greater than the required strength. So every design philosophy covering this main equation. So here in working stress design method, the allowable strength, also called design strength, is equal to the nominal strength divided by factor of safety. If the nominal strength is 50, then we will divide by 2 by something 1.5 factor of safety. We will get the allowable strength. Means if the nominal strength is 50, if we are taking the factor of safety is 2, then the allowable strength is 50. If it beyond the 50 MPa or something, so the structure may be fail. So for this, we require a large section to bear the applied stresses. So this is the main concept of working stress design method. I mentioned generally that the allowable stress is less than or equal to the ultimate stress is less than or equal to the nominal strength divided by factor of safety. So remember this, by doing this, nominal strength is divided by factor of safety. This means that the design strength are reduces. We are reducing the design strength by factor of safety, and hence the loads are same as we are taking the loads, working loads, applied loads, without load factor we are taking. So in this working stress design method, we are reducing the strength of a section of a structure, and we are taking the loads as it is. Here you can see that the different properties in this section area moment of inertia that are large enough to prevent the maximum values. Maximum applied axial force, these are the load effects like the axial force, shear, bending moment, torsion, etc. So we are increasing the sectional property, cross sectional property, to bear these load effects from exceeding the allowable value. Since the allowable values are reduced because we are divided by nominal strength divided by the factor of safety, it was decreased. So we are producing large sections. So large section, why we are producing large section? Because to prevent the structure from these load effects from exceeding the allowable values. Here allowable values are the design strength, means the design strength should be less than or equal to the required strength. So we are increasing the sectional property to increase the allowable values, so to prevent the load effects from exceeding the allowable values, the permissible values. So this is the working stress method, that the allowable strength is equal to the nominal strength divided by factor of safety. Nominal strength is calculated through different formulas mentioned by different codes. We are reducing the internal ability of a section to to resist the applied load effects. So we are reducing this property. So by reducing this property, we require large section. So by providing large section in a structure, it become uneconomical. Remember this. Here the main point of working stress design method is that without applying load factor, we are taking loads to calculate the required strength, and also by dividing nominal strength by factor of safety, we will reduce the strength. And this is the main point of a working stress method, that we are using working loads to calculate the required strength, and allowable strength is can be calculated by nominal strength, which is through formula we can calculate the nominal strength, and dividing the nominal strength by factor of safety, we will gain the allowable strength. So this for this the section will be large, and they are uneconomical for design. Normally these are in practice for bridges, dams, etc., for these type of structures. So for a building, etc., the limit stress design are in practice. So this is the today's video lecture. Hope you got it. Thanks to everyone.